Hey Dr. Lane, so I'm doing another reassessment for Chapter 7. Let me just read you the problem one more time. A coffee filter of mass 1.8 grams dropped from the height of 4 meters reaches the ground in a speed of 0.8 meters per second. How much kinetic energy did the air molecules gain from the falling coffee filter? Start from the energy principle and choose as a system the coffee filter, the earth, and the air. Okay, so I did all my calculations right and everything on my past one, but you send it back and you told me to focus on why is the kinetic energy and the potential energy equal to one another, and is this always true? Now, no, it's not always true. The reason it is in this case is because well, you're deriving it from the energy principle. So energy is kinetic plus potential energy. Now, while this is moving, it's really supposed to be the change. While it's moving, kinetic energy increases and potential energy decreases. Because if you would look at it at a standstill, it's not equal to one another. Like when the coffee filter is at rest at the top, wherever it's at, its kinetic energy is going to be zero, while its potential energy is going to be something else, whatever that value might be. But because it's falling, that's what we're calculating. That's why it's able to. That's why we are able to equal both of these energies to one another, because one of them will be increasing and the other is decreasing. So it's like going at a constant rate. One's going up, one's going down. Now I wrote all my variables there: mass 1.8, height 4 meters, speed 0.8 meters per second, and the system. And there I have everything. I'd switch my mass from grams to kilograms right there, and my potential is mass times gravity times height. So I do all that and get 0.07056 joules, and kinetic is 1/2 mass times velocity squared. So we had all that. We plug it in and we get 0.00057 joules. Now we take the difference of the potential energy and the kinetic energy, and that's how much, because in our problem originally it asked us how much kinetic energy the air molecules gained. So at the bottom, after everything was done, that's what we were able to calculate: potential and kinetic, as it from the beginning, from initial to the end. At the bottom of the ground when it fell, we calculated the potential energy that it had throughout the whole thing, and kinetic, and we were able to subtract them, and the energy that was gained by the air resistance was 0.0699 joules. So hopefully that kind of explains more of what this problem had to do. Oh, and also the coffee filter, earth, and air were in the system. Now, obviously, what am I trying to say here? Obviously, the earth and the coffee filter of the system weren't the ones that gained anything. The air was the only thing. So that's why this value belongs to it. Thank you.